Event-driven architecture is often described as a pattern. In real systems, it behaves more like a force that shapes system behavior over time. It changes how information spreads, and over time, it changes how systems are allowed to evolve. On AWS, this behavior never appears automatically. It only emerges when communication is designed around events instead of requests. This episode builds the mental model behind that shift. An event is a statement of fact about a state change. Not an instruction, not a workflow step, not a request for work. It is a system saying something became true. That distinction is what allows components to make decisions without coordinating execution paths. Most AWS systems begin life request-driven. APIs call services, services call other services. Dependencies are formed along execution paths. When events are introduced later, teams often keep the same mental model. Calls are replaced with triggers, but the dependency structure remains. That is not event-driven architecture. That is control flow stretched across a network. Request-driven coupling is built on knowing who to call. Event-driven coupling is built on knowing what happened. Producers expose state changes. Consumers decide whether those changes matter. Neither side knows who else is involved. Coordination moves from runtime control to shared domain knowledge of state changes. A common assumption in AWS systems is, we use AWS Lambda, so we are event-driven. Lambda is compute. It executes reactions. It does not define relationships. You can build a tightly coupled execution chain entirely out of Lambda functions. Those functions can still depend on timing, ordering, and upstream behavior. Event-driven architecture is not defined by what triggers compute. It is defined by whether decisions can occur independently in time. The starting point for event-driven architecture is not messaging, it is state ownership. State ownership means one service, and only one, is responsible for a piece of truth. That owner emits events when its state changes. All other services are downstream interpretations of that change. This forces service boundaries to align with data responsibility, not technical convenience. Services stop exposing procedures. They expose state transitions. Without this boundary discipline, events degrade into just another integration mechanism, not an architectural model. Lambda functions live at reaction points in the system. They consume events, transform them, enrich them, trigger new state changes. But Lambda does not define how the system behaves. The real architectural control point in an event-driven system is the event transport layer because that determines delivery semantics, fan-out behavior, failure modes, and timing. Those mechanics shape how the system behaves under scale, stress, and partial failure. That backbone, not compute, is what determines how your system fails, scales, and evolves. Event-driven architecture is not about asynchronous execution. It is about systems evolving through published facts instead of directed commands. On AWS, designing this way means separating state ownership, event publication, and event reaction. That is what allows systems and teams to evolve independently over time. In the next episode, we move from the mental model to the mechanics and examine how Event Bridge, SNS, and SQS each create different architectural behaviors.